Stick around to the end to find out more information about a free escape room convention coming up this weekend. If your spider sense is tingling, then it's because we're going to talk about sensors. Today we're going to talk about the different types of sensors you're likely to encounter or use in your escape room. And of course, to start off with, there's the simplest one, the none more black, the most infamous of all the sensing types of switches, and that is the dreaded reed switch. Ooh, that's right. This guy has been the point of much contention and debate in many escape room forums for a very long time, and it's all over this little guy here. Just this little tiny glass little capsule here. Now, this is generally the most basic reed switch you're going to encounter. They don't all have three prongs like this. This one is specifically to do normally open and normally closed. They do make just normally closed reed switches, which means that the contact on the inside is touching, and when you bring a magnet next to it, because that's what it senses is magnetism, it opens up. Or there's normally open, which will then touch when the magnet is brought close to it like this. There are different types of these that exist. They're usually found in different types of housings. You'll find some that have a plastic housing around them that are still this size, that have a little black molded plastic around it. And there are kind of the much larger housing that are intended for doors, like door alarms and things like that. And you'll find these have three little screws on them. And if you open them up, they do the exact same thing. It has these little prongs here. And there are also these kind here that you'll encounter. These are also very common. And these, you draw a hole, run these in, and these basically flush mount into a door frame or something like that. And then you have your magnetic end, and when it comes in contact, it will activate or deactivate, depending on what you're doing. Now, as you know, normally open means on a switch means that the contacts are not touching. But what's interesting about these types of reed switches, and you want to be careful when you're buying these, is these will say normally closed, but that means when the door is normally closed. So be aware that when you're purchasing these to get the right thing, because you might end up buying the wrong kind of reed switch. Here's essentially what's going on inside of a reed switch. You have these two reeds, hence the name, and if it's a normally open sensor, they have this here. They're separate, right? But when you bring a magnet close to it, these will touch. They will force themselves together, and when they touch, you will get a connection, and then electricity flows through it. But then if it is a normally closed switch, it starts open, and when it pops, it breaks the circuit. So that is the simplest way to explain how a reed switch works. And so now let's show you a practical way to wire it together. All right, here we go with our old reliable setup here, a whole bunch of alligator clips, a little 12-volt battery, 12-volt light. And just like any other switch that we've talked about in other videos, you are basically interrupting. Imagine this is a push button. That's all this is. So this just goes in between the positive line of the thing that's being powered. All right, so now I'm going to turn this on, and as you can see, this is now currently set for normally closed, which is why the light is on. But if I bring this magnet close to the thing, it turns off, just like that. Now again, not all of these have this this three-rail setup, this three-pin, whatever you want to call it. But if I move it to here, to the other side, now the light is not on until the magnet gets close. And it turned on like this. What's interesting is you're not going to be able to hear this on my microphone, but you can actually hear a tiny little click, 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 just a very tiny. So you can actually, experienced players, if they know reed switches in play, you can actually get it up close and you can hear the mechanical movement of the switch. So just be aware of that. I mean, it's not something you should ever have to deal with, but it's not as loud as a relay, obviously, but you want to be aware that that's a thing. Also, speaking of relays, a lot of people will tell you that reed switches are best used as signal voltage. Like, you don't want to put these in line with your maglock, because the problem with reed switches is they are prone to failure, especially cheap ones. Because what's happening is you're getting all these power surges going through, and these little tiny pieces of metal in here can fuse and start to break down because they're a mechanical switch. So over time, they can become messed up if you're running too much voltage, amperage, and whatever. And even though it says, some of these say they're rated for a lot of voltage, spikes in power and amperage and all that stuff can break them. And so a lot of people will say that they are best used for things like signal voltage on a relay. So if in this situation you would have it running from the in to the negative if you're doing a low signal. So that way it's only getting a small amount of voltage. It's just triggering a signal voltage. It's not taking on all of that energy at once. So just keep that in mind, that these will last you a lot longer when used as trigger voltage. All right, so we're going to come back to magnetic sensors a little bit later with a different type of sensor, but let's talk about the next simplest thing that you can encounter for escape rooms, pressure sensors. And this isn't atmospheric pressure, this is physical pressure. And this little sensor here, well, I say little, this thing's pretty big. This sensor here is what goes into a car seat to detect whether or not somebody's sitting in it, and to let the car know whether or not it should make an irritating noise if you're not wearing your seatbelt, essentially. But this is good if you need some sort of chair sensor when somebody has to sit down and it detects somebody is in there. Now, there's different types of pressure sensors. There's floor mats, and there's one you can buy, and there's ones you can make your own. Old school haunt stuff with like cardboard and tinfoil and things like that. But there are different types of pressure sensors, generally for like chairs and stuff. But these are very interesting because each of these little dots is a sensitive spot, right? So if I push here, let me turn this on. If I push here, that comes on. If I push here, 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 nowhere else. It's only those spots. Boom, 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 boom. And of course, if I put my whole hand on it, it doesn't matter where it happens. It'll happen anywhere like this. So these are great when you need to detect pressure of some sorts. Now, one thing you don't want to get confused with is there are things that look like these, but are not these. They're actually more like variable resistors or variable potentiometers or soft potentiometers. They're the different names for them. And they're things like this. This is a soft potentiometer, and these are meant to be hooked to an Arduino to measure the pressure and stuff like that, and where things are. And depending on where you're doing this, it acts like a potentiometer, making something brighter or darker or whatever. So you have to monitor that. Things like this, they're still soft, they're still flexible like this. And there are sensors like this, pressure sensors, variable resistor pressure sensors that look like this with a little circle. But the problem with them is they have to reach a certain threshold to actually give you what you need. And so this is binary. This is on and off. Those, they can detect, so they're not entirely reliable. Then you have things like this, which are flex sensors. And so what these do is as you bend it like this, it'll actually detect how much force, how much flex it has, and adjust accordingly like that. So, if you had this inside of something you had to bend and get us to reach a certain, let's say you had this in a fake metal bar, right? Like a piece of rubber that was a fake metal bar, and you had to be a strong man, and you bend this, and this knows at the degree that you bend, and then it triggers something. So just be aware that you may see other soft-bodied things like this, but they are not like this. Next up are these guys, which you've seen me talk about in other videos in the past. These are proximity sensors, and these detect proximity, but it depends on what type of material that it is trying to detect. And these are capacitive, and this is inductive. Capacitive means it senses organic materials such as flesh and like wood and paper and things like that. Some of them are sensitive enough to do that, detect non-organic materials. And then you have inductive, which is for metal and magnets and things like that. These things here, and a lot of these are used in industrial applications in case something like is getting too close to something, it knows to back off. Like it uses it as a limit switch in a lot of cases and stuff like that. And there are things that use capacitive like table saws that will detect, if it detects flesh, it kills the blade and drops it into the table. So these are 3 different types, and they all work relatively the same. And as I've said, we've talked about these in the past, and so I'm going to talk about them a little more and show you how to wire them up. So the one thing you'll notice on these is they are not color-coded in the way that you are normally used to. This has a blue wire, a brown wire, and a black wire. And the black wire is a signal wire. It's not ground. It's not negative, because why would it be? And I don't know whose decision this was. This is just how almost all of them that I have ever seen come. The brown wire is your positive, and the blue wire is your negative. And there are two flavors of these proximity sensors. You have NPN, which share the positive of whatever you're trying to power, and you have PNP, which share the negative. Most of the time, you're going to want to get NPN, which is how it will work with almost all your controllers and things like that. But as I mentioned in the controllers video, you may have to use a PNP with certain controllers. So just be aware of what you actually need and what this is. And almost all of them that I have ever come across tell you how it's wired and what it is right here on the side of the device. But when you buy them, they will tell you as well. But let's go over a little bit of wiring here. So let's say that you have this. We'll say this is your LED right here. Here is your battery. And then this is your sensor right here, okay? And then this will be your plus, your negative, your plus, your negative, and then this is your positive, your negative, and your signal. Think of it kind of like how a relay switch kind of is set up and stuff like that. So in this case, we're dealing with NPN like this. And that means that this signal is going to be attached to the negative wire. Actually, let me change that there a little bit for you. Let's use a different color so it's easier to see what's going on. There, your signal there is green, like that. And of course, your negative is going to run to your negative like this. And then finally, the positive of your LED will run to the power, and so will this. So what's happening is your battery is powering your battery is powering your sensor, and then the sensor is basically turning it. I'm skipping a lot of technical terms in this stuff, and if you want to deep dive more into find out more of the science behind it, I highly encourage it. This is just so you kind of understand the wiring with it and everything like that, just so you know. And so this is powering this based off of this. It's using like it's a non-mechanical contact that is opening and closing. Call it the gate, whatever you want to call it. Different things have different terms, but a lot of them work the same. Anyway, so this is how you wire up an NPN like that. A PNP would be wired in a different way. So let's do that. The only real difference is just what shares what. So here we go. Do that again. So now the signal wire will run to the positive of what is being powered, like this, and your positive your positive still runs to your positive, but now your negative is shared. Like that. So that's all you really have to remember. And if you wire it up and it doesn't work, then because you got it backwards, just switch it. And so now I will show you what it looks like in practical application. All right, so we've wired up the proximity sensor here, the NPN capacitive touch sensor, and the blue is going to the negative. The signal, the black, is going to the negative. And as you can see, the positive and the positive are being shared. So what's going to happen is when I touch the top of this sensor, the light will light up. Boom, there it is, just like that. And you don't actually have to touch. You can actually hover right above it a little bit. Like this has a short detection range. So that's something else you're going to want to keep in mind when you get a proximity sensor, is it will tell you what the read range is. And some of them have a very small read range, like 2 to 3 millimeters, 6 millimeters, something like that. But there are ones that can read up to, a very long distance, like easily an inch, like 20, 25 millimeters, stuff like that. And you'll see ones that are like this. These generally, not always, but generally if they're blue like this, they'll be inductive, and if they're yellow, they'll be capacitive, but not always. And also you'll see ones that look just like this, but they're like this big around. They're huge boys, and they can detect a very far distance. So just keep in mind the read range and also what you have to detect through. So like I have this piece of foam board here. If I put this on top, it doesn't detect through that foam board because this foam board is too thick. So, and that's not that thick, if you notice. But let's try a piece of like thin acrylic here that I have. And I'll put this on top of that, but it reads through that. So be aware that the read range is very important. Like I'm not even touching that, and it's picking up my finger. But different materials will also react differently. Like I said, the capacitive ones can detect wood. Like if it actually is touching the wood, it's picking up capacitance, and that will trigger it sometimes. Sometimes like any other organic material, like paper, things like that. But it just depends. Once you get it in there, you may have to put a little bit of a spacer or something when you put it upside down in the thing. Some of them have mounting holes like this, as you can see, and some of the ones like this have to be kind of like screwed in and mounted, and which is why it comes with hardware and things like that. So just be aware that this one, the read is here on the top, like this has a little target to show you. So just be aware that different proximity sensors function differently. In the same family as proximity sensors, you have touch sensors. And they are technically still just proximity sensors that are just capacitive, but they tend to be used more for touch very specifically. And this is one of the ones you'll find very commonly here. The little blue sensor here that has a little silver spot, which is where you touch on the back. And these are 5 volt and intended for Arduino. These tend to be used in low voltage stuff like Arduinos, 5 volts, things like that. The read range on these is not great. I will tell you that right now. Over here, we have these little tiny red ones. These little tiny red ones are actually have a really good read range. They're still 5 volt, and they come in like a little board all together. You have to snap them apart and things like that. But they do have quite the read range where they can detect pretty far away. So if you're looking for something with a lot of read distance that is small, but also for 5 volts, these little boards are really good. Now, it took me a little while to find. At the time, I was having trouble finding these, but these have become more common now, to find a 12-volt touch sensor that was small, that would take up a small amount of room. Because these things right here work great, but I needed something to fit into a small space, and so it wouldn't take up a lot of room. So I was looking for something, and I found these on eBay here, and there are these little 12-volt sensors. Now, these are very interesting because they have to be modified in a very particular way, because when you get them, they start on. When you power them up, the item starts on, so it basically starts normally closed. And if you unsolder one of the resistors on the instructions tell you to undo, then it starts off. It starts normally open. It also starts off as latching, and if you remove a resistor, then it becomes momentary. And of course, then you can adjust the sensitivity by soldering across one of the other 2 ports here because it starts high sensitivity and you can go to low sensitivity, but I don't think you'd ever want low sensitivity in an escape room. You want to make sure people connect with what you're using. So having said that, let me power this on here, and you can see that the read range on this guy, this one's set up for latching, by the way. The read range on this isn't terrible. Like, that's actually not too bad right there. That's about 6 millimeter right there, I think, if I remember correctly, like that. And this is one of those ones that I told you about that can sense the organic material there. If I put the paper up like this, there we go, just like that. And it's detecting me through the paper there. So this one works, no problem, all the way through, just like that. So if you're looking for a small 12-volt sensor that'll fit into a small project, these little guys are very handy. We're now going to swing back around to the magnetic sensors because we have one of the most versatile sensors for detecting magnetism that is on the market, and there's a lot of stuff to go over with this. These are called Hall effect sensors, and they look like a transistor. These little tiny things here, but they work similarly, but not to one. The best way I can explain this is just think of this like an NPN proximity sensor. You wire it up the same way, and it works similarly, okay? I'm not going to go into the science. You can look all that up and see the differences between what we talked about earlier and this, but just know that this is basically a solid state read switch. Now, I know some people are going to hear that and grind their teeth, but that is the simplest way of putting it. There's no moving parts, and it works like a read switch, but it has way more versatility and options of things you can do with it. So allow me to kind of draw out, just again, so you know what's going on here. So this, I'm going to move him off to the side. We'll say this is your Hall sensor. Now, a Hall sensor from the top, if you look at it from the top, it's shaped like this. It has this kind of whatever shape. this almost pyramid, but not kind of shape like that. So that's what these lines represent, are these ridges. So that's kind of the front, as I like to say. Okay, so it's got 3 bars coming down like this, and for the most part, you're going to have your positive, your negative, and your signal like this. Different brands may change the pinout, but this is what I've commonly seen, just so you know, like that. So now you're going to have, you're going to be passing power through to something. So here is our power, our positive, negative, and here is our LED switch right here with our legs as such. Okay. So in this situation, we're going to have negative, positive, like this. The signal will be going into the negative as before, and then the negative will be feeding into this, and then the positive will be feeding in, sharing across like that. And so when you bring a magnet close by, now the Hall sensors tend to be pole specific. So one side detects the north pole of a magnet, and if you bring the south pole, nothing will happen. But if you go to the other side, so let me show you what I'm talking about. So this would be north, this would be south, just so you understand what I'm saying there. And also I realized I should probably do this, so visually this makes a little more sense for you. There you go, like that. So be aware. Now there are 3 different types of Hall sensors you're likely going to encounter. You're going to have linear, you're going to have latching, and just on-off, right? On-off basically means if you get a magnet close to one side, it turns on. You come away, it turns off. And if you bring the other side to this, turns on, turns off. Okay, that's very basic. It's like a reed switch. Latching means that if you bring the north side to it, it stays on until you bring the south side or the opposite pole towards it, and it turns off. So they will stay on and everything like that. Now, linear are some of the more interesting ones that I've played with. And what happens is, as you get the magnet closer to it, as the magnetic field increases, so does the power it sends to the item. So if this was a linear Hall sensor, and as I get closer, the LED that it's connected to will get brighter and brighter until it gets to full power. So very interesting kind of stuff there. And I'm going to wire one of these up so you can see what's going on. So I've wired up a latching Hall sensor to my device here. I've got this hooked to my LED, my battery pack, same as what we've been already doing here. And here's a magnet, so I can very easily tell which way is north and which way is south. So I'm going to bring this close by, and you'll see the read range on this is real nice here. That's the wrong side. And right about there, look at that. That's like almost an inch away. Like, that is pretty impressive. And it turns on and stays on. And of course, if I come in from the south here, and look at that. That's a really, I'm going to turn this sideways so you can see kind of what's going on here. So look at the read range on that. Like, that is pretty good. Just look at that. That's like easily an inch of read. So, sorry, not read, Hall. Ha ha ha. All right. Anyway, so that is what a latching sensor will do. The one disadvantage of these is in their state like this, they cannot be wired in series. Reed switches can be wired in series, which makes them very good for that fact. These cannot be wired in series without a lot of extra components, just so you know. So now we've turned that on, and I'm going to bring this in, and and you see it turns on, and when I get away from it, it turns off. But if I turn the magnet around, nothing happens because it is just detecting the one side like that. So also, these can handle a fair amount of voltage. Depending on the manufacturer and the specs and everything, they can handle 5 to 6 volts all the way up to some of them like 24 volts or whatnot. So these are 12 volts are safe with these. Obviously, be aware of what the amperage rating for all this kind of stuff is when you look into that. But that is the basics of Hall effect sensors. Now, I'm sure you're asking yourself, hasn't somebody taken a Hall sensor and put it on some sort of board so it's not just a loose component? And the answer is yes, they do exist. Here's one of the styles right here. This little black board has a Hall effect sensor, 3 pins, very easy to hook up. These are sold as Arduino components and stuff, but these can still handle your same amount of voltage. The pins are different. The negative is on this side, and the signal's on this side, and the positive's in the middle, as opposed to the other way around that that the other sensors are. So again, like I said, they're not all created equal. So just be aware when you look at that, make sure to check the pinout and stuff like that. So, but yeah, these little boards here, if you need to, if you need something like this, because this has a little resistor and an LED on it. So when the signal gets close, it lights up. So this is just kind of an easy to detect thing. But check this out. This is a great little board from Escape Room Techs. This is their FX51 Hall effect sensor board. And there's a lot going on here. Like, there's more than I can cover, but they have covered it all very well on their website. But this thing has a lot of options that you can do with these. And what's interesting about them is they can detect the rotation of a magnet, the distance of a magnet. Basically, you can use these to almost like an RFID puzzle, because you can have 4 objects, or even more if you use rotation. But you can have 4 objects, and you can determine north and south, and also close distance and far distance. So you can basically, without having to wire up RFID and program that or rig up a bunch of stuff, you can just use these in the same way. Now, these can be wired in series, which is very interesting, but they've come in very handy for certain things that we have used them for. They have little dip switches because they have a bunch of different modes and ways of detecting different things. And again, I'm not going to go into all of that, but I will show you some examples of the things you can do with them. All right, so I've wired this up in the most basic configuration that you can do here, and I've just got it set to detect a magnet of any kind. These things have bipolar and unipolar detection. So like a Hall sensor can detect north and south, or it'll just detect any magnetism of any kind, which is what I'm pretty sure I have this set to right now. So if I do this, it comes on. I'm going to flip it around. Comes on. It's just detecting magnetic range. I could set it for only detecting north and only detecting south. I can also set it to detect at a very particular range. So I could tell it to detect, let's say here, like this. Like once it gets to a certain distance, then it detects. But what I can tell it to do is detect within a very small range. So what'll happen is if once it starts detecting, like here, once I move past that point, just like a few millimeters, it'll turn itself off then, which is very interesting as well. So again, so many options you can do with these things. And I'm going to show you something else that actually goes with this so you can run different things in series. What you see here is an FX51 sensor board. It's essentially one of these, but it relies upon this to do the thinking. This is basically just a Hall effect sensor board. It's similar to what I showed you earlier. It's like one of these, but on steroids, obviously. So you can run one of these without one of these, but you cannot run one of these without one of these. And you can wire up a lot of them. I want to say 16. I know I've done at least 10 before. And you can do this with what's called a gated mode, which will sense the distance of the magnets and stuff. So again, very, very easy to program all this stuff. You just have to follow the instructions, and the documentation's all online. But I'm going to show you kind of what's going on here. So I have a popsicle stick with 2 magnets taped to it because high tech. And now I'm going to place this onto here. And I'm going to push this button, which is going to learn the magnet's position. Okay, so I'll place this on here like this. Let's set that. I'm going to set it a little bit high, and now it's on. So now, if I do this, nothing. If I do this, nothing. If I set this here and slowly lower this magnet down towards this one, it'll come on only in a very slight range. If I move it a little bit down, it goes off. If I move it a little bit up, it goes off. I know that's kind of hard to see, so I'm gonna turn it sideways here and try to do that for you from the side there so you can see exactly what's happening. So you can see how sensitive that is. I move it a little bit to the left, off. Move it a little bit to the right, nothing. There we go. And so you can get it very, very dialed in right there. So that is just one of the things you can do with these to control what's possible. And these are solid state contacts, so there's nothing that makes clicking noise, anything like that. Also, these, you have them start on, normally open or normally closed. You can have them, again, so many options. I'm not going to go over all of them, but I am going to show you one more thing. This is Escape Room Tech's indestructible knob. It is made of hardcore materials. You can swap out the knob here and everything like that. It has a set screw and things like that. and they spin 360 because, you know, you use potentiometers. Potentiometers, if they get cranked too far one way or the other, they break, and they're very fragile. And so they came up with this using one of their FX51 Hall effect boards. And so it's stuck here on the back like this. And there's a magnet in here, and it just detects constant, and so this just constantly rotates. So there's nothing to like break, and it's made of steel, and you can't snap it off. So it's real nice. They're very handy. I will tell you right now. We've used them for some stuff, and they're great. So, but again, because this board can detect rotation, I can set, like right now it's set to detect here, right? So now I have a piece of tape, and so if I do this, if I do this, it's got a 15-degree kind of like. And you can actually dial this in to be more specific. You can actually set the degrees to be more precise. But let's say I wanted it to detect here. Well, all I have to do is press the set button, and now it'll detect from there. So you can change the puzzle very easily on the fly. And if you hook this up to some of the FX sensor boards, like we showed here, these guys, you can have an array of knobs running. And if like you have a little valve set here, and you twisty, twisty, twisty. And if when you use these with their badass controller, you can actually use some NeoPixel and get a valve game where the lights move up and down. There's a lot going on with these, but the fact that you can use these for rotation it's magic to me. It's astounding, quite frankly. So that is one of the many crazy things you can do with Hall effect sensors. And I highly encourage you to pick up some of these and play with them. Hey, did you know there's a free escape room convention happening this week? That's right, Recon, August 23rd and 24th. We're even going to do a talk on creativity. What? I know, it's crazy. There's a bunch of other speakers and things going on, so go check it out. Go to the website below and come join us for all the fun. Hey guys, make sure you check out some of these other videos we have here. And of course, if you want to keep up with anything we're doing, make sure you subscribe, click the bell, and make sure you also check out testsubjects.com for more info. And if you have something very specific you want us to go over, please let us know in the comments below. See you next time.